Welcome back. We have a collision problem here, and it reads: two bodies, P and Q, with masses 18 kilograms and 6 kilograms, are initially moving at 20 meters per second and 10 meters per second respectively in the same direction, collide and then move separately. After impact, there was no change in mechanical energy, and body P attains a velocity of 15 meters per second, maintaining its initial direction. What is the velocity attained and the direction of body Q after collision? Okay, so if I should represent this on a diagram, we have body P of mass 18 kilograms initially moving at 20 meters per second, and we have body Q of mass 6 kilograms that is moving in the same direction as P at a velocity of 10 meters per second. So this is the situation before collision. So after collision, the two bodies move separately. That is what we have understood. After collision, we have the 18 kilograms mass that move with a velocity of 15 meters per second. So we are asked to find the velocity of the 6 kilogram mass after collision. So that will be VQ. Okay. For now, we don't know whether after collision body Q maintains its initial direction or not. What can only tell us whether it maintains it or not is to find its velocity. If its final velocity is positive, it means it has maintained its initial direction, but if it is negative, it means it has reversed its direction. Okay? Now, the other question that I can ask myself is, what type of collision is this? The type of collision. From the question, it says no change in mechanical energy. So a type of collision in which there is no change in mechanical energy. Bear in mind that mechanical energy means kinetic energy. So if there is no change in kinetic energy, we're talking about elastic collision. And for a perfectly elastic collision, we know that the bodies separate, right? The bodies separate after collision. So at least the question gave us an idea. All right. If there is no change in mechanical energy, it means the total kinetic energy before collision is equal to total kinetic energy after collision for an elastic collision. Now, applying the principles of conservation of linear momentum, it says that the total momentum before collision is equal to total momentum after collision. So if I want to find the total momentum before collision for body P and Q, it will be the mass of P, the initial velocity of P, plus the mass of Q multiplied by the initial velocity of Q. This should be equal to the mass of P multiplied by the final velocity of P plus the mass of Q multiplied by the final velocity of Q. The question is asking us to find the final velocity of Q and also state the direction of Q after the collision. If I should substitute the values, the mass of P is 18 multiplied by the initial velocity is 20 plus the mass of Q is 6 multiplied by the initial velocity is 10. This is equal to the mass of P is 18 multiplied by the final velocity it attained is 15 plus the mass of Q is 6 multiplied by the final velocity of Q, which we are finding. So 18 times 20 gives 360. 6 times 10 gives 60. This is equal to 18 times 15 gives 270 plus 6 VQ. So 360 plus 60 is 420. This is equal to 270 plus 6 VQ. If I collect like terms, it will be 420 minus 270 is equals to 6 VQ. And that gives 150 is equals to 6 VQ. So if I divide both sides by 6, VQ, that is the final velocity of body Q, is 25 meters per second. Okay, so which means because it is positive, it means the final velocity is in the same direction as its initial velocity. Okay, so but what proves that this is elastic collision? We say for elastic collision, total kinetic energy before collision must be equal to total kinetic energy after collision, right? That is only for elastic collision. So I want to prove that this is an elastic collision. Let's try to find the total kinetic energy before collision. So the total kinetic energy before collision will be half the mass of body P, the initial velocity of body P squared, plus half the mass of body Q multiplied by the initial velocity of body Q squared. This will be half. The mass is 18 for P. The initial velocity for P is 20, so it will be 20 squared plus half multiplied by the mass of Q is 6. The initial velocity is given as 10, so that will be 10 squared. If you compute this, half multiplied by 18 multiplied by 20 squared gives 3600 plus half multiplied by 6 multiplied by 10 squared gives 300. So it means the total kinetic energy will be 3600 plus 300, that gives 3900 joules. So this is the total kinetic energy before collision. So let's find the total kinetic energy after collision. The total kinetic energy after collision will be half mp, the mass of body p, the final velocity of body p squared, plus half the mass of q multiplied by the final velocity of q squared. That will be half the mass of p is 18 multiplied by the final velocity of body p is 15, right? Yeah, is 15, so it will be 15 squared plus half the mass of q is 6, the final velocity which we calculated was 25, so it will be 25 squared. That will be half multiplied by 18 multiplied by 15 squared, that is 2025, plus half multiplied by 6 multiplied by 25 squared, that is 1875. If you add these two, 2025 plus 1875, you get 3900. So you see that the total kinetic energy before collision is equals to total kinetic energy after collision. This type of collision is what we call elastic collision. Elastic collision. So it means for elastic collision, total kinetic energy before collision is equal to total kinetic energy after collision, which means there is no loss in kinetic energy during the collision. Okay, so kinetic energy was not lost during the collision. Okay.